So, hello everyone. My name is Akshat Wagmare from CSE1 department, final year. So today I am here to explain you about the visualization in big data engineering. So the big data engineering forms the backbone for processing colossal datasets. However, the volume, the velocity, and varieties, the three V's of big data often make it incomprehensible. Data visualization is critical, transforming these complex datasets into understandable and actionable intelligence. So, what does the data visualization means? The data visualization bridges raw data and meaningful insights, enabling exploration of trends, identification of anomalies, and discovery of hidden patterns for big data engineers. It's about building robust systems that empower analysts and business stakeholders to make swift, informed decisions. Integrating visualization into big data pipelines enhances understanding of operational performance, customer behavior, and system health. For instance, real-time analytics dashboards can alert engineers to system bottlenecks. In financial services, it helps detect fraud, and in healthcare, it reveals treatment efficiency. So, what makes the big data big? So, first of all, for understanding the visualization of big data, we need to understand what is big data. The big data is defined by the five key characteristics mainly known as the five V's: volume, velocity, variety, veracity, and value. These five V's are very important as these are the main characteristics of the big data. These dimensions collectively describe the immense scale, speed, diversity, trustworthiness, and business worth of modern datasets. So understanding them is very crucial. So first of all, moving to the first characteristic, that is volume. The volume refers to the immense quantities of data generated and stored, often reaching petabytes or even exabytes. Sources include transactional data, social media, IoT sensor data, and log files. For instance, companies like Walmart process millions of transactions per hour. This scale instances distributed storage and processing frameworks like Hadoop and cloud data lakes. So moving to the second characteristic, that is velocity. The velocity is the speed at which the data is generated, collected, and processed, often in real time or near real time. Examples include financial market data, sensor readings, and fraud detection systems. High velocity demands low latency processing, enabled by technologies like Apache Kafka for ingestion and Apache Spark. Variety. The third one is the variety. The variety describes the diverse forms and types of data. Unlike traditional structured data, big data includes a vast array of formats like structured, semi-structured, and unstructured data. The structured data means relational databases, semi-structured means XML, JSON file, and a CSV file, and unstructured data includes text, emails, social media posts, audio, images, and video. Moving with the fourth characteristic, that is veracity. Veracity refers to the quality, accuracy, and trustworthiness of the data. Big data often comes from multiple potential unreliable sources, leading to issues like noise, inconsistencies, and errors. Now, moving to the fifth one is the value. Value is the ultimate goal, the business worth and insight extracted from the other four V's. Without value, the data is just costly and complex. Organizations invest in big data to uncover patterns, predict trends, optimize operations, and create a new revenue stream. So, why data visualization essential for big data? The challenge of raw data. The big data presents a significant challenge. Raw, tabular information, often petabytes in scale, overwhelms humans' analytical capabilities. Millions of rows and columns make it nearly impossible to identify patterns, outliers, or trends to finding a needle in a hashtag. What is the power of visualization? The data visualization bridges the gap between complex data and human comprehension. By translating abstract numbers into intuitive graphics like dashboards, heat maps, and scatter plots, visualization leverages our innate ability to process visual information rapidly. This instantly reveals patterns, trends, and outliers that are invisible in tabular formats. Okay, moving to the next part, that is the big data lifecycle and visualization roles. The first one is the collection gathering data. This foundation stage involves acquiring vast volume of data from diverse sources characterized by volume, velocity, and veracity. The sources is OS, web analytics, IoT devices. The methods used are real-time streaming for continuous ingestion, batch processing, and specialized APIs. Challenges are ensuring data equality, managing velocity, some becomes sometimes challenging. Integration means the data sets are combined to create a holistic view, breaking down data silos. The purpose is the unifying related data, that is That basically means the sources into a coherent dataset or data warehouses for comprehensive analysis. The challenge involves resolving schema mismatches, handling different data formats like JSON, XML, CSV. The tools and approaches used are data integration platform, data warehousing, and data lake architecture. The third one is the refining of for clarity, also known as data wrangling. This stage ensures data accuracy, consistency, and completeness. Dirty data leads to skewed analysis. The common issues include duplicate data, missing values, inconsistent formats, outliers, errors, irrelevant information. The techniques used are imputation for missing value, standardization, normalization, duplicate removal, parsing test. Visualization rules include the essential for detecting issues. Histograms highlights outliers, scatter plots reveals correlations or errors. Heat map shows patterns of missing data. Visualizations mean the process integrated data is transformed into visual or graphical representation, making it digestible and easily understandable for the non-tech person also. This is the bridge to actionable insights. The objective is to rapid exploration, pattern recognition, trend identification, and discovery of relationships hidden in tabular data. The types are basic charts, pie chart, bar chart, line chart, heat maps, tree maps, network graphics, graphs, geographical maps, interactive dashboards. The tools and principles used are Power BI, D3.js, Matplotlib, Seaborn. So moving to the next part, that is the analysis. With visual data, analytics delivers deeper to extract meaning insights. The method used are statistical analysis, machine learning, data mining, and so on. Visualization roles include validating assumptions, identifying anomalies, discovering correlation, and so on. The outcomes gives the deriving actionable intelligence for business strategies. Moving to the next part, that is the presentation. The final step is to effectively communicate findings to diverse audience, often non-technical stakeholders, to drive decision making. Objective: the conveying complex analytical results clearly, concisely, and persuasively. Storytelling elements includes comprehensive reports, interactive dashboards, and presentations. The best practice includes tailor presentation to the audience, focus on key messages, and clear language. Moving to the next part, that are the core principles of effective data visualization. The clear, first of all, is the clear. The visualization must be instantly understandable, minimizing cognitive load. This means selecting the right chart type, clearly labeling axis, and avoiding jargon. A clear visualization of sales data, for example, immediately shows top performing regions that include reduced cognitive load, appropriate chart selection, and direct labeling. Concise. Each visualization should be convey one primary message, especially with big data. Avoid cluttering, excessive data points, or unnecessary decorative elements. The data ink ratio principle is crucial here. For instance, a concise pie chart for market share shows dominant players more effectively than one with too many slices. The moving on to the next one is a consistent that the uniform color scheme, scales, and styling across all visualizations create a coherent narrative in big data. Consistency helps users compare and interpret data across different views without confusion. The next one is the correct the data should be accurate. Data representation is non-negotiable. Visualization should be not distorted data, mislead with inappropriate scales, or present information out of context. Ethical data visualization requires rigorous validation, clear source attribution, and avoid pitfalls like 3D charts that obscure values. The first one is a compelling. Effective big data visualization engages audience and prompts actions. It tells a story, highlights relevant insights, and connects with the audience goals. So, what are the main popular visualization techniques for big data that are used recently? That are interactive dashboards, heat maps and geospatial maps, time series charts, and a network graph. So, we will learn one by one. The first one is the interactive dashboards. The interactive dashboards are dynamic visual interfaces consolidating key performance indicators and metrics from vast datasets into a single view. They enable real-time monitoring and immediate insights through drill down, filtering, and dynamic updates, often using streaming data. The next one is the heat map and geospatial maps. These represent data densities, magnitude, or concentration across geographical regions or categorical grids using color gradients to reveal hotspots and cold spots. These visualizations are critical for identifying hidden spatial patterns. The third one is the time series charts. The time series charts analyze data points collected sequentially over time, tracking trends, identifying sensationality, and detecting anomalies. Essential for understanding historical performance and forecasting. Common types include line, area, and candlestick charts. The next one is the network graph. The network graph visualizes relationships and dependencies within complex datasets, representing entities as nodes and interaction as edges. This helps uncover structures, community, and critical part often invisible in tabular data. So next one is the tools powering big data visualization nowadays. The first one is the enterprise platform for scalable business intelligence. These use Tabule, Power BI, QuickLook are used. The open source solutions for flexibility and customization like Apache Superset, Grafana, and Kibana are used. Custom and AI-driven approaches for advanced data analytics, big data analytics are Python ecosystem that is used by Matplotlib, Plotly, Seaborn, R ecosystem, and AI-powered predictive analysis is used. The real world impact. The visualization driving the real world impact includes first of all, we will move to with the real world example like the Facebook photo analysis, users behavior at a scale. Social media platforms like Facebook processes billions of data daily photo and video uploads. Advanced visual analytics including image recognition, object detection, and scene understanding algorithm identify faces, objects, landmarks, and emotions. The fraud detection in financial institution use data visualization to combat credit card fraud by analyzing billions of real-time transaction patterns, anomalized behaviors, or identify examining transaction attributes, geostatistical data, historical patterns, and device information. Scientific breakthrough medical innovation in genomics and bioinformatics. Big data visualization is vital for interpreting massive molecular datasets from projects like the Human Genome Project. Researchers use specialized tools to identify disease patterns, pinpoint genetic markers, discover therapeutic targets, and understand evolutionary relationships. So, overcoming challenges in big data. The first one is the handling data variety and complexity. Second one is the managing data velocity and volume, and third one is the avoiding information overload and ensuring clarity. So, visualize to unlock big data truth power. So, visualizing serves as a critical bridge transforming vast data repository into clear, actionable insight. The first one is the transformation from raw data to strategic insight. The second one is the empowerment, data-driven decisions making across roles, and the third one is the future vision, immersive and intelligent visualization. So that is for today. If you like my video, please like and subscribe, and thank you for watching my video.